Hey everybody, welcome back. If this is your first time on my channel, this video is a follow-up to my first toy packaging video, but as requested, I'm going to be going a little bit more in depth. If you want to see the first one, I'll throw up a link on screen here. I'm going to be making the packaging for this 3D printed Yeti that I made. I didn't make a tutorial for the toy itself because I'm still a noob when it comes to 3D modeling, and there are far better creators to learn from in that regard. I'll throw some recommendations of the creators that I myself used to learn from in the description below. Anyways, you know the YouTube drill. Leave a like and subscribe if you haven't already, and let's jump into the process. The first step is preparing the 3D model of the toy to create the negative that will be used to vacuum form over. The thickness of the interior packaging needs to be accounted for when we create the negative, so the way to do this is to add a displacement modifier in Blender. This adds thickness to the model itself. You may notice there's a big box covering the toy's feet. That's because any areas that have too many nooks and crannies won't perform well in a vacuum former, so it's best to box those areas out. With the 3D model ready, I create the two sides of the packaging, just two basic cubes, and along with them I create two sets of cylinders that will act as pegs and notches. Those will help the two sides align in the final product. Make sure one set of cylinders is around 20% smaller than the other. This will allow for the thickness of the vacuum former sheet, just like the displacement modifier earlier. Selecting one of the cubes made earlier, apply the Boolean modifier and select one of the cylinders as the target. It doesn't matter which one you select at first, but if you're selecting the bigger set of cylinders, you'll want to use the difference modifier, and if it's the smaller set, you'll want to use the union modifier. Once you've joined the first set of cylinders, select the other box and join the second set of cylinders. If you did this correctly, you should now have a positive and a negative side that can plug together. Using the same Boolean technique as with the cylinders, we're now going to apply the difference modifier to each cube using the toy as the target. Once you have applied the modifier to both sides, the bucks for the vacuum former are complete. Export each side as its own STL file and then generate the G-code for it with your preferred slicing software. I use Ultimaker Cura, but Prusa Slicer is also great. I didn't go into too much detail on vacuum forming in my last video, but this is my vacuum former. It's the Mayku Formbox, and while this video is not sponsored by them, I'm very happy that there's a consumer product available that will guarantee I'll get consistent results. If the Formbox is out of your budget, there are also cheap dental vacuum formers out there, although they're a little limited in size. There's also plenty of DIY options out there, but that's where consistency might suffer. A vacuum former has two main parts, a heating element at the top to make the plastic soft, and a flat bed with lots of little holes on the bottom that connect to a vacuum so that it can suction the plastic around whatever is placed on top. We'll be using the vacuum former to make the interior packaging sleeve. That will help to keep the toy from rattling around and potentially breaking. The sheets I get from Mayku have guidelines which are really helpful when you're first getting started, but I find that they are entirely dependent on the object you're vacuum forming. If the object is relatively shallow in depth, you won't want the plastic to be too melted. For what we're making today, however, the settings are perfect. You want the plastic to be soft enough to ensure it fills all the spaces of our box. I forgot to add these during the modeling step, but I think drilling them out worked just as well. You're going to want to add some holes along the interior of the buck. I just used a small drill bit and made sure to add holes at all the deepest parts to ensure the air would be sucked out properly. Along with the two-sided interior packaging option, I created one where I split the front into two smaller pieces. This was just an extra step of adding an additional cube to the center and using that difference modifier again. This style of packaging isn't necessarily better or worse, but I wanted to show some of the different variations you can make. You can see how this one still keeps the toy in place but doesn't obstruct the view in the display window of the final packaging. The next step is straightforward. We need to trim the excess plastic around the form. I've tried using a utility knife for this, but I find that I get a cleaner edge with scissors. Use whatever you're most comfortable with though. Moving on to the outer packaging itself, the first thing you'll want to do is grab the dimensions of the inner packaging. I'm using the 2 bucks I printed and giving myself a few extra millimeters in each direction. As for the design of the box, you could certainly design the template for the box yourself, but there are so many free to use box and packaging templates available, it's very easy to grab one and tweak it to your needs. I've been using my current template for a while across different projects, so I don't exactly remember where it's from. However, you can find really high quality ones at templatemaker.nl. You can even plug your dimensions and avoid not having to do it in the editing software. Speaking of editing software, there's a slew of programs you could use to design the packaging. I'm using Adobe Illustrator, but Inkscape is free and can do everything you'll need. If you're having trouble coming up with a design, take a look at some of the packaging you have around your house. You're sure to find some ideas and inspiration. See what works and what doesn't for your piece. Also, while you're designing, keep in mind where the seam of the box is going to be, and try to make sure it faces the back side of the box. Big print companies don't print the image with the cut lines overlaid. However, since we're doing this by hand, it's almost necessary to keep them visible. Make the cut and fold lines a shade similar to the box that will be just barely visible when you print it out. If your package has a window display, make sure to mark that out somehow as well. Once you like how the packaging is looking, make a test print with some cheap paper and fold up a mock-up. Seeing it assembled helps you notice anything that needs to be changed. If everything looks good, it's time to move on to the final print. I'm using an inkjet printer that can print up to 13 inches wide, but if you can't get a hold of a printer that size, you can always take advantage of a print service. For the paper you should use, commercial products use paperboard. You can buy this online, but it's really expensive if you're not buying it in extremely large quantities. My best results have come from using 99-cent poster board. I trim it down to a size that fits my printer and usually get 2 sheets per board. Once you've got your packaging printed out, it's time to cut it. Take time to make sure you aren't accidentally cutting a line that is meant to be folded. I like wearing gloves during this step to make sure I don't get any oils on the paper. After cutting everything, if your box has a display window, don't glue it just yet. I didn't do this step for the tutorial, but you'll want to spray the paper with a UV archival finish. This will keep your box from fading or getting fingerprints on it. Now that you've protected the print job, it's a good time to glue it into place. I like to use a basic cyanoacrylate glue, but anything that can bond plastic to paper will work. If you're wondering what I used for the window, I bought some inkjet ready transparency sheets, the kind that are used for screen printing or for old school overhead projectors. You can find this at an Office Max or Office Depot. With the window in place, it's almost time to fold the box. However, you can't just jump straight into folding it, as that will likely make the paper tear. To make sure your folds come out crisp, it's important to score the paper at the fold line. Scoring is done with a blunt tool that will stress the paper out but not cut or tear it. Once you've scored all the lines, you can fold the box up and glue the seam. And now we're in the home stretch. I doubt you need instructions for this part, but grab your toy, place it in the inner sleeve, and slide that sleeve into your box. Close the flaps, and that's it, you did it. Alright everyone, thanks for making it this far. I hope you learned something from this tutorial, and if you've got any further questions or if I missed a step, leave it in the comments and I'll reply. Stay tuned for more interesting projects and I'll see you next time.